first thing you need to do is you need to go to aplusstudents.com. You need to go to the website. Once you're on the website, you select math as your subject. This is a grade 9 math lesson, and the name of the topic is probability. I'll give you the chapter number and the lesson number. The chapter number 10, lesson number 1. Chapter 10 and lesson number 1. What we would do is we would identify dependent and independent events. So let's see what basically a dependent and independent events are. In case of dependent events, one outcome will be dependent on the other outcome. Let's see, if we have a bag and we have 3 marbles in it, let's suppose. If we have 2 red marbles and we have 1 blue marble in it. Okay, so we have total of 3 marbles. We have 2 scenarios. What happens is, if we select the marble from the first bag, okay, 1 marble is to be, okay, I'll write down the statement. A marble is to be selected after another. We have a way of representing the information. How many marbles do we have? We had a total of 3 marbles, right? So when we have 3 marbles as a choice, what we can say is either we can pick a red or we can pick a blue. We try to draw a tree diagram. A tree diagram means we make branches. Either we can pick a red marble or we can pick a blue marble. Agreed? In the second case, if the first selected was red, we can again select another one. It could be either red or it could be blue, right? The first one could be a red, I'll just explain this. And it can be a blue and blue. The difference between these two questions would be that I would use an additional term over here that says a marble is selected after another, selected and replaced. A marble is to be selected and replaced. And then another is selected. Another is chosen. Okay. The difference of the words is replaced, and we do not have a replaced in the first case, right? So what happens is, I'll make the tree diagram again. Okay. Let's look at the scenario. What happens over here is, when the first marble was chosen in the first scenario, what happened was, in the first case, we had 3 marbles in the bag. How many were reds? There were 2 reds and 1 blue. If we take out one red, how many reds are left? One red is left. Okay. There were two reds out of three, and there was one blue out of three. If we took out one red and not replace it, that means one red is taken out. There is now one red out of the two, and there is only one blue out of two now. But what happens is, if for the blue marbles, if we had one blue marble out of three, if we take one out over here, how many blues would be left? There would be no blue marbles left, right? There would be no any more blue left because we had blue, red, and red. If you already take out the blue, only two reds are left, right? That means two marbles would be red only. But in the second scenario, okay, let's see. If we need to find the probabilities over here, what happens in a probability is we say, I'm saying it, this is red and red. Agreed? This was red and red. So what happens in red and red is, in probability, and means multiplication. That means first is red and the second one is red. That means when we multiply them, answer comes out to be 2 out of 6. The probability is that if you do this experiment 6 times, 2 times there is a chance that both of them would be red. Then we have red and blue. What was the probability of red? Red was 2 over 3. Once we took out one red, the total number of marbles were reduced to 2, and there was one, it is again 2 over 6. Then we have blue and red. The probability of blue was 1 upon 3 into 2 upon 2. That means 2 over 6. But what should be the probability of blue and blue? Can we take out blue and blue without replacement? This was 1 upon 3 into 0 upon 2. That means the probability of finding 2. This case was without replacement. That we selected the first marble and we did not replace it. Okay. What you need to remember is the total sum of the probabilities. This is 2 upon 6, right? 2 upon 6 plus 2 upon 6 plus 2 upon 6 plus 0. The sum of the probabilities would always be equals to 1. In probability, it cannot exceed 1. The probability of anything cannot exceed 1. It cannot be less than 0. It cannot be greater than 1. Okay. So this case was without replacement. Let's look at another scenario in which the marble was replaced. Okay. How many red marbles were there? There were 2 red out of 3. Just let me separate this. I would tell you what I'm just doing this working to differentiate between dependent and independent events, right? So we had, okay, there were 2 reds, 1 blue. Agreed? If you take out 1 red and you put it back in the bag, so did the number of reds or the total number of marbles decrease? No, it stays the same, right? And blue would be 1 upon 3. If you took out the blue and you put it back, the blue is still 1 upon 3 and reds were 2 out of the 3. That means the total number of marbles in the bag would never change. Agreed? Just a moment, let me move this. Okay, now let's see. If I would say I want to find what are the probabilities and what are the possibilities over here. So can I say this was red and red? That means the probability of red was 2 over 3. Multiply by 2 over 3, it comes out to be 4 upon 9, right? This is with replacement. The previous one was without replacement, okay? If the first one was red and the second one was blue, that means the probability of red was 2 over 3 into 1 upon 3. It comes out to be 2 over 9. If the first one was blue and the second selection was a red, that means 1 upon 3 into 2 upon 3. Normally, the students will have a question that why is blue red and red blue not the same, right? They are not the same because if your teacher says that you and student B got the first and the second position, that means the teacher is only saying that the first two positions were given to you. You got the first and the second, or the second position, right? But the teacher did not identify which student got which position. If you got the first position, then the student B will get second position. But if student B got the first position, then automatically you get the second position, right? So when the position is therefore red blue and blue red is not equal, okay? Blue and blue would be 1 upon 3 into 1 upon 3, that is 1 over 9. And we know that when we add 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 1, the total of the probabilities would always be equals to 1. Okay. Now let's see what is the difference between dependent event and independent event. When we were doing replacement, right? When we replaced, so what happened? It's an independent event because we still have two red marbles. So any one of the red marbles can be selected again, right? So when we have with replacement, we say they are independent events, right? That means any one of the red can be selected. We do not have a restriction. But in the first case, without replacement, this would be a dependent event. Why? When one of the marbles of red was already selected, then we are only left with one selection, one choice of red, right? So we cannot have two reds again to be selected from. So dependent event means the second outcome is dependent on the first outcome. Independent would mean they have no link between them. They can be chosen in any other possible way. Okay. Let's move ahead. Let's do this simple statements. Okay. We simply write dependent, independent. Okay. We are rolling a die and calling a neighbor. They are independent, right? Because we can call a neighbor first, then roll a die. If the score is 5, 1, 2, 3, 4, 5, 6, anything, right? So it does not make any score comes on the dice, we still have to call the neighbor. But if the question was roll a die and if the score is even, then you call a neighbor. So that means we are giving a condition. Whenever there is a condition, they are dependent events, right? Okay. Draw a card from a deck and toss a coin. They are still independent events. Okay. Pick a pencil from a box, put it back again, and pick another pencil, right? we saw over here with replacement. Okay. So we can say they are ND because we're putting it back and independent events. Okay, let's see. Pick a glass from a cupboard, then contains 50 glasses and break it. Dependent. Agreed? Why? The 50 glasses, you break one, that becomes 49. It's dependent on the first one. Pick one marble each from 7 different bags. If there are 7 bags, selecting one marble from each bag, would it be affected? If bag A we select a marble, bag B we select a marble, bag C we select a marble. So there is no condition saying that if you select from bag A, then you have to select from bag D, right? So no condition over here. So these would be independent events. Okay, the next one, draw 2 marbles from a bag, one after another in sequence. These would be dependent events, right? Pick a pencil from a box, put it back, again pick a pencil from a different box. Different. The different box is the difference over here. In the previous question, it was saying same box. From a different box. Same box would be dependent. Yes, same box would be dependent and different box would be independent. Agreed? Sorry. Reading a page from a book and mark it as read. Then again pick an unread page. So if you've read a page from a book, let's suppose a book has 100 pages. If you have read 20 pages and you need to select an unread page, so you cannot select from those 20, right? Because it's already marked as read. So you have to go through the unread pages. But still, you are marking it read. Previously, it was marked as, there was a page that was unread, right? The unread page, you change the category of the page to be read now. So now it depends on, if you mark a page to be read, then the unread pages would be decreased. Increase in the number of read pages will decrease the number of unread pages. These are dependent events, right? Draw a card from a deck. A deck has 52 cards. Again, draw a card from a different deck. It says a different deck. So there would be independent. So if we were selecting 2 cards from the same deck, it would be a dependent event, right? But if you are selecting 2 cards from 2 different decks, those are independent events. Because if, let's suppose, from the first deck we get 10 of spades. We have another deck. When we pick the card, we get a 10 of spades. It could be identical cards. But from the first, if we only had one pack of cards, if the first card we pick 10 of spades, can the second card be the 10 of spades from the same? No, because every card is single in quantity, right? It's a single card. It says arrange the letters of the word testing, then rearrange them. So would it be dependent or independent? It is dependent, right? Because we only have the word testing and we only have these alphabets. So we say this is a dependent event, right? So let's look at some more examples. Okay. let's suppose if we have, let me just copy. So I would say this is question number 1 and question number 2. Let this be question number 1. We need to identify whether it's a dependent or an independent event. Let's see. For the first question, they are saying you flip a coin. You flip a coin, then roll a fair six-sided. See, we can draw this diagram. Coin has a head and a tail, right? If we get a head, then we roll a fair-sided six-sided dice. 1, 2, 3, 4, 5, 6. Okay, I'm just making a rough sketch over here. What we can say is if we had a head on a coin, can we get a 1, 2, 3, 4, 5, 6? Can we get the answer as head and 1? Can we have head and 2, head and 3, head and 4, head and 5, head and 6, right? But let's suppose if we got a tail, can we have tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, and tail and 6? We can say we can also get tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, and tail and 6. Okay? What they are saying is the coin lands on the heads and the die shows a 1. Is the result of this outcome dependent on the other outcomes? Is it dependent or independent? It's independent because head and 1 will come only one time, right? So we can say this event is independent because the score, or we getting a head, on a coin will not affect the score on a dice, right? So this would be an independent event. Let's look further. A bag contains 8 red marbles and 4 blue marbles. Let's try doing that. Red, 8 reds and 4 blue. Okay, I'm just writing in a pairs of 2. If this is our given bag. Eight red, 4 blue marbles. You randomly pick a marble and then pick a second marble without returning it to the marble to the bag. What happens is we had 2 possibilities. We can select a red marble or a blue marble. How many reds were there? There were 8 reds out of 12. How many blues were there? There were 4 blues out of 12. If one red was selected, then again in the bag, how many marbles are there? They could be red and blue only. If one red was selected and without returning, right, it's not replaced. That means the total number of marbles has been reduced now. So red has been reduced to 7 and blue was not chosen, so blue stays as. If the first one was chosen as blue, then again we can have, if one blue was taken out, how many blues are left? 3 out of 11 and 8 out of 11, right? So what we can see is the result, the first marble is red and the second marble is blue. let's see. First is red. This would be red and red, red and blue, blue and red, blue and blue, right? So what they're asking is the first marble is red and the second marble is blue. This event, this is the outcome. Would Is this an independent event or a dependent event? This is a dependent event. Why? Because the probability of red was 8 upon 12, right? Which has been changed to 4 upon 11. There is a decrease in the denominator. A decrease in the denominator shows us that the outcome of the second is dependent on the outcome of the first. Agreed? So we can say this is an dependent event. Agreed? Okay, let's look at more examples. A few more. Just a moment. For the next question, it says, question number 2, 3, and 4. Let's see, question number 3 and 4. Question number 3. Question number 4. In question number 3, they're saying a box of chocolate contains 5 milk chocolates, 5 dark chocolates, and 5 white chocolates, right? We have milk chocolates, dark chocolates, and white chocolates. Agreed? We have 5 milk, 5 dark, and 5 white. That means 5 upon 15, 5 upon 5 out of 15, and 5 out of 15. You randomly select and eat 3 chocolates. They're saying the first piece is a milk chocolate, second is dark, and the third is white. Okay, let's see what the tree diagram would be. This is without replacement, obviously, right? Because you're eating. You ate 3. So if you are eating a chocolate, you cannot replace the chocolate, right? So first one was a milk chocolate. If you had a milk chocolate, you took 1 milk chocolate, then what can you eat next? You can still eat the milk chocolate, a dark, or a white. There were 15. Now there are 14 in total because you ate 1 milk chocolate, right? The milk chocolate was 5. Now there are 4 left. But you did not eat a dark. You did not eat a white. So the question says, you ate first milk chocolate, the second one was a dark chocolate, and the third one was a white chocolate. Agreed? You had a milk chocolate, then you ate then what we can say is we still have 3 possibilities, right? We can have a milk, we can have a dark, or we can have a white. So what happens over here is, if you ate 1 dark, so the denominator now becomes 13. This is 4 upon 13. This was 4 upon 13 because 1 milk was already consumed. 1 dark is already consumed. They cannot be 5 upon 15. But this is 5 upon 13. And then you eat the white chocolate. So my question is the result, is this sequence, do they have any dependency? If 1 milk chocolate was eaten over here, is it changing the result of dark and white? Yes, it is, because there were total 15. Now they are total 14, and now they are total 13, right? Agreed? So they should be because the probabilities are changing. The number of chocolates are changing. They is dependent events. I'm not trying to find the probability right now. I'm just trying to differentiate between a dependent and an independent event. Okay. For the next question, it says a cooler contains 10 bottles of sports drinks. Let's highlight 10 bottles of sports drink, 4 lemon lime flavored, 3 orange flavored, 3 fruit punch. Okay. So we can say we have lemon lime, we have orange flavored, and we had fruit punch. Okay. 3 times you randomly grab a bottle, then return the bottle. The bottle is being returned. I can make the tree diagram to explain you. This would be a very messy diagram. Okay. I say lemon, fruit punch, sorry, orange, and fruit punch. Lemon, orange, fruit, lemon, orange, fruit, orange, fruit. That means the denominator will never change. The denominator will be constant, right? 3 plus 3 plus 4. That means this is upon 10. This is 4 upon 10. It is 4 upon 10. And this is 4 upon 10. The denominator does not change. So we can say that selecting a lemon, orange, or a fruit punch, selecting one does not affect the other because they are returned, right? Independent events. Because the juices are returned. The denominator, the total number of juices does not get reduced. It's a fixed number. It's 10. Okay. Okay, let's go to the website. The chapter number was 1 minute, please. Uh, 10 1. Chapter number, sorry. Grade, why am I grade 10s? Grade 9s. Chapter number 10 1. Let's do the test. Or no, let's start with some questions. Okay, let's do some questions more. It says, for question number 5, just asking us, this is a statement given. This is question number 5. Laura pulls a coin out of her pocket and places it on the table. Then she reaches back in her pocket and takes out a second coin. They're two separate coins, right? The results of either, we can say we have coin 1 and we have coin 2. Coin 1 has head 1, tail 1, and coin 2 will have head 2 and tail 2. That means they all are different outcomes, right? So we can say they are independent events. That means the result of one event will not affect the other event. Agreed? Okay. The next question, they say, Kenny picks a marble at random, puts it back. Whenever it's returned. Question number 6. Just a moment, please. Let me align this. If this is our question number 6, it says, Kenny picks a marble at random. That means it can be any. Puts it back. That means replaced. And whenever something is replaced, it does not affect the outcome of the other. So we can say these are Would it be dependent, independent? Yeah, independent, right? Because it's replaced. Agreed? Okay, sometimes I just also need to verify. Okay, let's look at question number 7. The question says Ella picks a marble at random without replacing. She picks up a second marble. This is without replacement. Question number 7. Without putting the first marble. Without means without replacement. If she is not replacing it, that means the denominator will change. Agreed? So that means they are dependent events. Agreed? Let's have a look at another example. Garrett is making a beaded necklace and plans to reuse each bead once. Okay. Question number 8, it says, this is the information that has been given to us. Question number 8, making a beaded necklace, plans to use each bead color once, selects a red bead, and then reaches for another color. So if rather than red, he chose a blue, then he cannot choose a blue, right? He has to go for another color. In this case, he chose a red, then he cannot go for a red, right? Because they're saying each color is to be used once only. That means they are, if selection of the first color will affect the selection of the second color, right? So we can say these are dependent events, because selection of first color affects the selection of the second color, because first color cannot be repeated. Agreed? Okay, let's have a look at a few more examples. In a card game, Wilson picks a card from a deck, okay, and does not put it back. Let's suppose we know that a deck of cards has 52 cards on it. This is question number 9. Picks a card from a deck but does not put it back into the deck. Afterward, John picks a card. Okay. If Wilson picked maybe a 2 of diamonds, right? Can John also pick 2 of diamonds? Not possible, right? This is not possible. Why? Because Wilson did not replace the card. Agreed? That means whatever Wilson will choose will affect John's result. That means they are dependent events. Agreed? That the outcome of one affects the outcome of the second. Okay. For the next example, in a history class, Kim has to select a historical figure to dress up as. Okay. No repetitions allowed. So for the next question, it says,
In a history class, Kim has to select a historical figure to dress up as. Richard will select one as well, but there are no repeats allowed. Okay. So if Kim becomes person A, then Richard cannot be person A, right? Still impossible because we cannot have duplicates. So what happens is the dependence event is the selection of first, that is Kim. If Kim selects person A, then Richard cannot select person A, right? So the results are dependent on each other. Agreed. Agreed? These are dependent events. If they were both allowed to choose any character or even a repetition, then it would not have been a problem, right? Then they would be independent. But selection by the first person affects the selection of the second person, then that is a dependent event. Okay, let's see in the test what do we have. Let's begin off with the test. Just a moment, let me copy. The first question says Conan took a coin out of his pocket. He flipped it and then flipped it again. Just a moment. The test, question number 1. This is question number 1 from the test. Will the outcome of one flip affect the result of his second flip? They're simply saying he flipped it again, right? But they're not saying that if he gets ahead, then only he's allowed to flip, right? They're not putting no condition. No conditions, right? There are no conditions. That means there are independent events. Okay. I just did the first one for you. I'll let you do the second one. The second question says, just a moment, please. Question number 2, if this is the information that we have, let me realign this. Okay. This was our question number 2. In this case, Mrs. Casey's class, the student pick unique number from a hat to decide the order in which they will present to their group projects. Carl picks the number first and Angie picks the number second, right? If there are 20 students in the class, there are 20 numbers in the cap, right? In the hat. If the first student picks a number, would the second student be able to pick the same number? Can two students present at the same time? Would two students be able to present same time? No, that's not logically possible because they would not be able to present and there would be a clash, right? So whenever the result of first event does not affect the result of the second event, right? It's independent. But if Carl picks the number 5, will Angie be able to pick number 5? Okay. Carl's number is 5. So Angie cannot get a 5, right? She cannot. That means if Carl has that number, Angie cannot. That means they are perfect. Thank you. They are dependent events. Let's look at another example. Okay. The next example says Carrot is making a beaded necklace. Okay, we did this similar question. If he puts a condition, then it would not be possible, right? Okay, question number 3. If he says that, okay, once he puts a condition, he is putting a condition that one color can be used once only. So are these two events dependent or independent? Color once only. He selects a red, then he reaches for another. Can he select two reds? He cannot, right? So what should be the answer? Yes, they are dependent, right? Agreed. Thank you. They cannot be independent because it needs to be chosen one. There is a given condition, right? Please do complete the remaining questions. Okay. Thank you so much. Have a nice day. Best of luck. Take care. Bye.